Let us wait for 2 minutes and then we will start. Oh, e to the power minus h t0 xs. Sorry, it was muted, so let us start again. Find Laplace transform of delta t minus 1. So to solve this, we will use time shifting property. So what is time shifting property? If xt is a time domain signal and its Laplace transform is capital Xs, then small x t minus t0, its Laplace transform will be e to the power minus ht0 capital Xs. Okay, so using this we can easily solve the problem. So now what we know? Do we know the Laplace transform of delta t? Answer is yes. We have solved in the previous lecture. It is 1, right? So if we shift the time, so delta t minus 1, its Laplace transform will be e to the power minus s into 1, so minus s. Okay, so this is our answer. Similarly, if we have question 2, find the Laplace transforms of delta t minus 2, delta t minus 3, delta t minus 4, or rather let us write delta t plus 1, delta t plus 2. So you people first try to solve this problem. You take 2-3 minutes, try to solve these 4 questions and then match your answer with mine. And if you cannot, I will solve the question for you. So there are 4 questions, try to solve it by yourself. Take 2-3 minutes. So what we know the time shifting property. And we have solved the Laplace transform for delta t minus 1. So similarly, we have the question to solve, that find the Laplace transform of delta t minus 2, delta t minus 3, delta t plus 1, delta t plus 2. Try to solve. So try to solve these four questions by yourself, and then I will solve it for you. If you can solve, just match the answer with mine, and if you cannot, I will solve it for you. Okay, so let us try to solve these problems. Again, we know delta t its Laplace transform is 1. So if we write delta t minus 2, its Laplace transform will be using this formula e to the power minus 2s, right? Okay. Similarly, if we have delta t minus 3, its Laplace transform will be e to the power minus 3s, right? If we have delta t plus 1, its Laplace transform will be e to the power s only. And if we have delta t plus 2, its Laplace transform will be e to the power 2s, right? So these are the solutions. Okay. Now we have question 3. Find Laplace transform of question 1 ut minus 1, question 2 ut minus 2, u is unit step. Okay, we have discussed in earlier session. Ut plus 1, ut plus 2. So these are 4 questions, and this will be solved in a similar manner. So take 1 minute and try to understand, or try to solve in which way we can solve this. Okay. First try to understand the question. Question is find the Laplace transform of u of t minus 1. So first we need to know the Laplace transform of ut, and then using the time shifting property we can solve this, right? So take 2 minutes and try to solve these 4 questions. If you can, you just match the answer with mine, and if you cannot, then I will solve it for you. Okay. Take 1 more minute and try to solve these 4 problems. Then I will solve it for you. But if you have any query, you can ask. Okay, so let us solve. We know that the Laplace transform of u of t is one upon s. Okay, so using the similarly time shifting property, can we write u of t minus 1 Laplace transform e to the power minus s multiplied with 1 upon s is equal to e to the power minus s upon s, right? In similar manner, we can write the Laplace of transform of u t minus 2 its Laplace transform is e to the power minus 2s multiplied with 1 upon s is equal to e to the power minus 2s upon s. So in similar manner, the Laplace transform of u t plus 1 is e to the power s multiplied with 1 upon s is equal to e to the power s upon s, and u of t plus 2 its Laplace transform is e to the power 2s multiplied with 1 upon s is equal to e to the power 2s upon s. Okay, so these are the answers. Hope you were understanding. If there is any query, you can ask. Although these are very simple examples, right? If you have any query, you can ask. Take 1 minute and try to understand what we have done here. Then we will go for the next property and next problem. Okay, so the next problem is question number 4. Find Laplace transform of e to the power minus at ut. Look, we have solved this problem in earlier session, but here we will solve it in different approach. So here the property is shifting in S domain. Shifting in S domain. So if u xt is a time domain signal and its Laplace transform is capital Xs, then If there is shifting in S domain, let us assume it is x plus a, x of s plus a. So here in time domain it will be e to the power minus at xt. Okay. So now if we write that ut is unit step response or unit step function, sorry, its Laplace transform will be 1 upon s for s greater than 0, right? So we have to find this. So if we write e to the power minus at ut, so its Laplace transform will be in this manner. It will be 1 upon s plus a. Fine. For s plus a is greater than 0, that indicates s greater than minus a. Okay. Now question 5. Find Laplace transform of e to the power at ut. E to the power minus 2 at ut. E to the power plus 2 at ut. And question 4, e to the power minus t ut. So you people take 2-3 minutes and try to solve this answer. First try to understand what is asked in the question and write, then try to solve. If you can solve, just match the answer with mine, and if you cannot, I will solve it for you. take 1-2 minutes more and try to understand what is asked in the question and try to solve. At least try to solve. If you can solve, it is fine, and if you cannot, I will solve it for you. Take 1 more minute. 1 more minute you take. Okay, so let us solve. Ut, again we have the solution that its Laplace transform is 1 upon s. So e to the power 80 ut, its Laplace transform will be this is for valid for s greater than 0. 1 upon s minus a, right? In this manner. If it is e to the power minus 80, then here it is x of s plus a. So if it is e to the power 80, then s minus a. One upon s minus a for s minus a greater than 0. That is s greater than a, right? Okay. So for e to the power minus 280 ut, its Laplace transform will be 1 upon s plus 2a for s plus 2a is greater than 0. That is s greater than minus 2a. For e to the power 2at ut, its Laplace transform is 1 upon is minus 2a. For is minus 2a is greater than 0, that is greater than 2a, and e to the power minus t ut. Its Laplace transform will be 1 upon s plus a, s plus 1, because here a is 1, right? For s plus 1 is greater than 0. Fine. So this is the solution. Please have a glance and try to understand what we have done. Then we will move for the next property. Okay, so our next problem is problem 6, right? Problem 6. Find Laplace transform of u of 2t. Now we need time scaling property. Time scaling property. Okay, so time scaling property is if xt is the time domain signal and its Laplace transform is capital X of s, then X of at, its Laplace transform is 1 upon a x of s upon a. So using this property, we can solve the good problem, right? Now we know that u of t, its Laplace transform is 1 upon s. So if we write u of 2t, its Laplace transform will be 1 upon 2 multiplied with 1 upon s by 2, and it is 1 by 2 multiplied with 2 upon s is equal to 1 upon s itself. Okay. This is the answer. Next, we will learn another property. Question 7. Find Laplace transform of u of minus t. Okay. So for this we need time reversal property. Time reversal. So if xt is the signal in time domain, its Laplace transform is capital X of s. Then x of minus t its Laplace transform will be capital X of minus s. Okay, so in similar manner we have now we have ut and its Laplace transform is 1 upon s. So u of minus t its Laplace transform is 1 upon minus s. So hope you are getting the points. If there is any query, please ask. If no query, then we'll proceed further. Question 8. Find Laplace transform of d dt of ut. So to solve this, we need again one more property, that is differentiation in time domain property. Differentiation in time domain. Okay. So let us solve this. Let us know the differentiation of time domain. If xt is a time domain signal and its Laplace transform is capital X of s, then ddt of xt its Laplace transform will be s capital X of s. Considering initial condition 0, is equal to 0. This is our consideration. Okay. Similar manner, if we have d2 dt2 of xt, then its Laplace transform is s square x of s. Similarly, it is also considering initial condition is equal to 0. And in the similar way, if we have dn dtn of xt, then its Laplace transform will be s to the power of x of n, x of s. Right? So using this property, please try to solve this problem first. You take 2-3 minutes and try to solve. Then I will solve it for you. Take 2-3 minutes. Take 1 or 2 minutes more and try to solve the problem by yourself. If you can solve, just match the answer with mine, and if you cannot, I will solve it for you. Take 1 more minute. Okay, so let us try to solve this problem. We know now that u of t, its Laplace transform is 1 upon s. So d dt of u of t. Of L Laplace transform is s multiplied with 1 upon s is equal to 1. Okay, so before we go to the next problem, okay, so next we'll move to the next problem. Find Laplace transform Laplace transform of t multiplied with ut. So for to solve this problem, we need to know the differentiating in H-domain property. Differentiation in H-domain. If xt is a time domain signal and its Laplace transform is xs, then minus d of ts x of s. It's it is u of t. Okay, t of u of t. Now u of t its Laplace transform is 1 upon s. So if we do multiply t multiplied with u of t, it will be its Laplace transform will be d dt dts of 1 upon s. That is equal to minus will be plus, right? It will be 1 upon s square. This was for s greater than 0. This is also for s greater than 0. Okay. Okay. Question 10. find Laplace transform of t square ut. So it will be in the similar manner. So you people try to solve this. You take 3-4 minutes and try to solve this problem. Then I will solve it for you. Okay, so let us try to solve the problem. We know that u of t its Laplace transform is 1 upon s for s greater than 0, right? And t multiplied with u of t, its Laplace transform is 1 upon s square. For s greater than 0. We have already solved it, right? Now, if we again multiply t, then what will happen? T square of ut, its Laplace transform will be minus dds of 1 upon s square is equal to 2 into 1 upon s cube, right? Is equal to 2 upon s cube, right? So this is very simple problem. It is also for s greater than 0. Now we'll move to the next problem. Integration and time domain property. Find Laplace transform of minus infinite to t u of tau d tau. So to solve this, we need integration property. Okay. So let us first know the integration property. Integration property, right? If xt is a time domain signal and its Laplace transform is capital X of s, then minus infinite to t x tau d tau. Its Laplace transform is capital X of s upon s. Okay. So now we know u t its Laplace transform is 1 upon s. So integration of minus infinite to t u of tau d tau is 1 upon s square. Right? Okay. So let us create some space. Next, we will move to question 12. Find Laplace transform of u of let us say u of t minus 1 convolution u of t minus 2. So it is very interesting property, that is convolution property. Convolution property. If x1t its Laplace transform is x1s, and x2t is x2x x2s. Then x1t convolution x2t its Laplace transform will be x1s x2s multiplied with x2s. Okay, so now what we know the Laplace transform of u of t minus 1. Its Laplace transform is that we have already solved, right? That is e to the power s, e to the power minus s upon this. We have already solved in previous examples. And u of t minus 2, right? U of t minus 2 its Laplace transform is e of e to the power minus 2s upon s. So u of t minus 1 convolution u of t minus 2 its Laplace transform will be e to the power minus s into e to the power minus 2s upon s square. is equal to e to the power minus 3s upon s square. Fine. So this is the solution. Okay. Now we will solve some more problems. This was the properties and some problems associated with the properties. Question 13. I will provide one question and you people will try to solve this. Find Laplace transform of xt is equal to e to the power minus j omega 0 t ut. First you people take 2-3 minutes, try to solve the problem and then I will solve it for you. Okay, so the question is find Laplace transform of xt is equal to e to the power minus j omega 0 t u of t. Find the Laplace transform. It will take 1-2 more minutes and try to solve it. You people take 1 or 2 more minutes and try to solve the problem. It is very simple one-line problem, but it is very important and interesting. Why important? Because in upcoming few questions we will use this. You people, you people take you people take 1 minute more, and then I'll solve it for you. Okay, it is very simple. If Okay, got it. Simply do it. If we have ut, its Laplace transform is 1 upon s. Now, if it is e to the power minus j omega 0 t ut, then frequency shifting in frequency domain property we will use shifting in h domain, right? This property we will use. So it will be 1 upon s plus j omega 0 for s plus j omega 0 greater than 0, right? Okay, this was the problem. Now problem 14 also very important to solve problem 15 and 16. So in between, if you have any query, you can ask. Find find Laplace transform of e to the power j omega 0 t ut. So again, in similar manner, we will solve it. We know Laplace transform of ut is 1 upon s. So e to the power j omega 0 t ut. Its Laplace transform will be 1 upon s minus j omega 0. Right? Now question number 15 is very interesting. Find Laplace transform of first we'll solve for cos. cos omega 0 t ut. You people try to solve this problem first. Take 2-3 minutes or 3-4 minutes. It's little bit tricky but interesting. Please try to solve and then I will solve it for you. You people take 1 or 2 minutes more and try to solve. Take 1 more minute and try to solve. Okay, let us solve it for you. Let us try to solve. We need these two results first to solve this problem. Why? Can we break cos omega 0 t into two parts? Half of e to the power j omega 0 t plus e to the power minus j omega 0 t. We can break it, right? Now we have the Laplace transform of into definitely ut. Mm, if we have multiplied ut, multiplied with ut, fine, we have the Laplace transform of e to the power j omega 0 t, and also we have the Laplace transform of e to the power minus j omega 0 t. Okay, so Laplace transform of cos omega 0 t ut its Laplace transform will be half of e to the power j omega 0 t ut's Laplace transform was 1 upon j minus j omega, right? 1 upon s minus j omega minus j omega 0 plus it will be e to the power minus j omega 0 t ut, its Laplace transform is 1 upon s plus j omega 0. Now we will simplify this. So is equal to half of s square minus j omega 0 square whole square. This is s plus j omega 0 plus s minus j omega 0 is equal to 1 upon 2 multiplied with 2s divided by s square plus omega 0 square, right? And it is equal to s divided by s square plus omega 0 square, fine. So what we will say, cos omega 0 t ut, its Laplace transform is s divided by s square plus omega 0 square. You take 1 or 2 minutes and try to understand what we have done, and if there is any query you can ask, then we'll go for the next book. You take 1-2 minutes and try to understand what we have done. Then we will proceed for the next problem. You take 1 more minute and try to understand what we have done. Okay, let us proceed for the next problem. Problem 16. Find Laplace transform of sin omega 0 t ut. Okay. Okay. So we can write sin omega 0 t ut is equal to 1 upon j2 multiplied with e to the power j omega 0 t minus e to the power minus j omega 0 t ut. Fine. So sin omega 0 t ut, its Laplace transform will be 1 upon 2 multiplied with e to the power j omega 0 t ut. Its Laplace transform is 1 upon s minus j omega minus 1 upon s plus j omega 0 is equal to 1 upon 2 this is s square minus j omega 0 whole square. Here it is j2. Okay, this is s plus j omega 0 minus s minus j omega 0 is equal to 1 upon j2 multiplied with s square plus omega 0 square into j2 omega 0, right? And it is equal to omega 0 divided by s square plus omega 0 square. Fine. So this is the complete solution. So let us stop today here. We will meet with some new exciting problems on next week. Thank you.